Rising temperatures represent a clear and present threat to life around the globe. But perhaps nowhere is the danger as looming as in the Arctic, where average temperatures are rising more than twice as fast as in the rest of the world. But temperature, a new study says, may tell only part of the story. Across the frozen tundra, a number of climatic factors are locked in a foreboding dance whose steps scientists are just beginning to decipher. And at the center of it all, the capacity of our planet to cycle carbon sustainably hangs in the balance. At 7 sites across the Alaskan Arctic, environmental researchers monitored the effects of 2 increasingly concerning phenomena: early greenup, the early arrival of a new cycle of plant growth due to warming, and delayed snowmelt, the persistence of snow until the beginning of greenup, which delays the next cycle of plant growth. In terms of carbon uptake potential, these 2 events have opposing effects, with early greenup increasing carbon uptake and delayed snowmelt decreasing it. The team discovered that the magnitude of these effects depends on how sensitive local plant life is to changes in temperature and precipitation. At higher latitudes, plants are generally more sensitive to these changes than those at lower latitudes. This sensitivity translated to distinct variations in how early greenup and delayed snowmelt affect carbon uptake potential. Generally, higher latitudes tend to receive a bigger boost in carbon uptake due to an early greenup. For example, for every 10 days greenup arrived early, the increase in carbon uptake at higher latitudes was approximately 150% greater than at lower latitudes. With respect to delayed snowmelt, which is associated with losses in carbon uptake potential, higher latitudes appeared more resilient than lower latitudes. For every 10 days of delayed snowmelt, carbon uptake losses at higher latitudes were 80% lower than those at lower latitudes. These findings, the authors say, should arouse some caution, as delayed snowmelt implies substantial losses in carbon uptake potential. Considering the effects of early greenup alone could lead scientists to overestimate carbon uptake at high latitudes. Overall, that could paint an inaccurate picture of health in the Arctic amid a changing global climate. This study highlights the important role played by snowmelt timing in Arctic ecosystems, and how that affects the ability of the Arctic to continue to serve as an engine for the global carbon cycle.